So if we want to solve this, 1 over y squared minus 1, 2 over y squared plus y minus 2, if you just looked at those as like the rational expressions each side that we have been working with, you could treat them the same way. Then those skills just get extended to solving for y in this case. You have to write out your restrictions just like before, but we're going to start it the same way that we have in the past. We're going to start by factoring everything that we can. So we're going to factor each of those denominators. So this y squared minus 1, what do we do with that? Difference of two squares. Oops. So, and then this one over here, can somebody factor that?
Y plus 2, y minus 2.
Okay. We all agree? No? Okay. This is no time for your jokes. So, all right. Now, looking at these two things, rather than jumping in and trying to create a common denominator, I think we use Ms. Kitchen's idea of just attempting to clear out these fractions as they are. So, if you notice that both of these have y minus 1s, everybody notice that? Y minus 1s on both sides. If I multiply both of these equations by y minus 1, just like in the previous problem, we can get some cancellation to happen, which makes the problem simpler. However, at the beginning here, we want to make sure that we restrict our values properly. So our y minus 1s, y cannot actually be 1. Because if it is, then you end up with 0, and we don't necessarily want that. So what happens then is the y minus 1s then can cancel away, and we should be ending up with something that looks like that. Questions? No questions. Oh, I crossed out the wrong thing. Speak up. Okay, so now we're good? Okay, so now what I have left standing is this. Y plus 1, and that's supposed to be equal to 2 over y plus 2. And now it looks like y also can't be negative 1 and it can't be negative 2. Y cannot equal negative 2. If it's either of those things, you get zeros in denominators. So now what I can do is everybody familiar with this cross-multiplying technique where since this entire side is being multiplied by y plus 2, I can multiply on the other side by y plus 2 and end up with just this times 1. And this one comes over here. So this is being divided by y plus 1, so I can multiply by y plus 1 over here, and I get this. 2 times y plus 1. So far, so good? Okay. So then, I could end up doing this. I've got y plus 2 equals, and distribute your 2, 2y plus 2. Because if you distribute the 2 here, that's what you get. Now we get our y's together and we try to solve it. And we should end up with one solution. However, the quadratics in these denominators, we want to check it and make sure that we didn't lose a solution when we did our cancellation. So we'll check it with a graph at the end. So we're going to subtract y from both sides, subtract 2 from both sides, and what do we get? Yeah. Yeah, so which is a number like any other. And if I plug in 0, 0 minus 1, that gives me 1 over negative 1. Then I have 0 plus 0 minus 2. 2 over negative 2 is also negative 1. So 0 turns out to be a solution. Now, if I actually do this without the factoring on the front end, let's look and see what happens. And this is just because we start with quadratic functions in the denominator. So let me cut this, get a new page, and we'll take a look. Okay, I can paste it here. Okay, so if instead we took a look at this, and instead of doing all of that factoring on the front end, if we started out with our cross multiplication, whoops, gotta take this back to the 10, then we could do this. So this whole thing is what's being divided on the right-hand side. And you get 1 times this whole thing, so this turns into this. And this whole thing is what's being divided on the left-hand side. So I do 2 times y squared minus 1. And if I now treat this like a quadratic, then I've got y squared plus y minus 2. Remember, distribute your 2. The thing I need to really emphasize with you all is that when you have quadratics, you need to make sure that you set everything equal to 0 so that you don't lose solutions. Some of you weren't doing that in the problem that had quadratic earlier, and it wasn't working out the way that it probably should. So now I want to set this whole thing equal to 0. I'll just put set to 0, since it's a quadratic, since it's a higher degree polynomial from just linear. So I'm going to subtract the y squareds from both sides, and all we're doing is rearranging things and grouping them. So I get just plain old y squared over here. Then I'm going to subtract the y as well. Subtract the y and subtract the y so that it cancels here. Then I'm going to add 2. Add 2. Add 2. So that way I've got 0 here equals y squared minus y, because I have 0y minus y here. And then the negative 2 and the 2, they cancel. So this is what I have. Now, when I factor this, you don't want to use quadratic formula, because that's overkill. It takes way too long. You can factor this and solve it. So it factors like this. We've been factoring things like this for the last week and a half. So here's the thing. Now it gives me 2 solutions. Y can be 0, or y equals 1. What's the problem, or is there one?
Oh, y equals 1 is a restriction.
That's a restricted value. So if you do your factoring on the front end, you'll catch that, and you'll prevent yourself from identifying solutions that aren't going to work. And I actually want to look at a graph of this and a graph of the original function, just to kind of show you the difference between the two. So this turns out to be what we call extraneous. It got introduced into the equation when we made it into a quadratic instead of a rational function. Because really, the degree of this is -2, not +2. So this is your only solution. You can find it either way. Questions about that? Okay, so stop my recording. So I'll post that on YouTube.